All right, let's do section 9.3, page 461, number 5, which reads, show that the natural log of x grows slower than x minus the natural log of x. So I'm going to let f of x be equal to x minus the natural log of x, and I'm going to let g of x be equal to the natural log of x. Now, as we've been talking about in this section, if g grows slower than f, then if I have the limit as x goes to infinity of g of x over f of x, this is going to be equal to 0. So the way to attack this problem is to take the limit as x goes to infinity of g of x over f of x and evaluate it and see if that's equal to 0. And if it is, then I'll know that g of x grows more slowly than f of x. So let's start by substituting in. So I'm going to have my limit as x goes to infinity of the natural log of x over x minus the natural log of x. And when I substitute in, I'm going to get infinity over infinity, which is an indeterminate form. It's not really a final answer, but it is something that I can apply L'Hopital's rule to. So let's do that. And when I apply L'Hopital's rule, I still have a limit, and I end up taking the derivative of the numerator and putting it in the numerator, and taking the derivative of the denominator and putting it in the denominator. So when I look at the numerator, the derivative of the natural log of x is what? 1 over x. And when I look at the denominator, the derivative of x is 1 minus the derivative of the natural log of x, which is still 1 over x. Now, when I look at that, I know that I can do some kind of algebra with this. So I'm going to start by finding a common denominator in the denominator. So I'm going to have 1 over x divided by, and when I find a common denominator, I'm going to get x minus 1. Well, when I look at that, I can do some canceling. I can cancel, in fact, let me just write that again. So I'm going to have the limit as x goes to infinity of 1 over x divided by 1 over x times x minus 1. And now I can cancel those 1 over x's in the numerator and the denominator, and I'm going to end up with the limit as x goes to infinity of 1 over x minus 1. And when I substitute in for the limit, I'm going to get 1 over infinity, which is equal to 0. And that satisfies the criteria that I had in the first place, which tells me that the natural log of x is going to grow slower than x minus the natural log of x.